Hello guys, so in today's video we are going to see how we can train our own RLHF based model, LLM model with your own human preference data to make it much more optimized and adapted to your own use case. So in this repo, we are going to see a very detailed demo. So personally, when I was searching for these kind of videos on YouTube and on internet, I was not able to get to see enough tutorials. So I thought, let me make one for everyone of you to see and learn from it. So this is going to be a very detailed demo session for training your own model. So before getting into the repository, I would like to cover some of the major concepts that we or anyone would like to know before getting deep dive into the model training part. So the base model that we are basically going to use is a pre-trained foundational model from Meta, which is LLaMA 3.18 billion model. So that is going to be starting point of all the steps that we are going to do. On top of that, then we are going to use the Alpaca dataset. So we are going to do supervised fine tuning using LoRa adapter on the Alpaca data to make it much more optimized and follow the instructions that we want to do. And after that comes a part of reward model training. So reward model is a separate model in itself, which is responsible for giving out scalar output based on how good the output from the LLM is. If it is good, it gets better scores. If it is bad, it gets lower score. So the idea is to get better and better scores so that our entire model could be more efficient for the output that we generally want. So reward model output is the scalar score as we discussed. Then comes the PPO-based RLHF. So PPO is kind of optimization technique which is used for updating your supervised fine-tuned model based on the reward model output. So we are going to see how exactly this is going to be trained and worked on. And then we have LoRa adapters. So LoRa adapters are nothing but a lightweight adapter that gets attached to a big LLM model. And generally we use this kind of training since we have low GPU with us, and it's like very expensive to have like bigger GPUs. So LoRa is a technique where using even smaller GPUs, we can train big LLM models. And then adapter merging is a technique where we just merge the LoRa adapters with the big model so that we can deploy it to production as a whole single model. So these are the workflow that we are going to see. So we are going to train a LLaMA 3.8 billion base model on the instruction Alpaca dataset to create a SFT model. We are going to train independent reward model. Again, the base model is going to be the LLaMA, but it has been trained on the preference dataset that we have with us. And once that is done, then we are going to do PPO-based optimization of the SFT model. So the reward model and the SFT model are going to work together. So SFT model generates output and reward model is responsible to attach a score to the output that it generates, and based on that it is going to update the model to make it much more better every time. So that is how this thing is going to work, and at the end we are going to get a inference ready model with us that we can deploy on production. So this is the default model in the dataset. So LLaMA 3.18b model that we are going to use over here from Hugging Face. So you have to like log into Hugging Face and get the access of this model to use it. So it requires some kind of authentication and permission from the Meta HF to get it used. So, and second one is the dataset that we are going to like fine tune the model on. So this is Alpaca clean, and here we can like see some input, output, and instructions as well. So we can maybe see some example. The world has been greatly impacted by COVID-19. Analyze the given text for its tone. So output is something like this. So we are going to first fine tune the LLaMA model on this kind of data set to make it better, and then train a reward model on top of it to do PPO and other stuff. So some output examples over here. So using base model, we get like something like this for the input, give 3 healthy tips. And after SFT, we get like much more like detailed description. And after RLHF, we get much more like detailed answer and a better answer. So now setting up or looking at the installation step, first we need to like set up the Conda environments. All the requirements have already been added over here, all the packages that we would require with proper versions. Then we need to do like local changes on top of the Conda environment, which is essentially some changes in the TRL core library and the modeling base model and the transformer modeling utils, and these patches have been provided in the repo itself. So if we go over here, so these are the patch files. So we just need to like run these commands and it will automatically do the changes for you. So that is one thing. And after that, we need to make sure we are logged into HF to use the LLaMA model. So after this step, we are ready to start with the training pipeline. So I have already like set up Conda environment and everything as we see over here. And now we can maybe start with the training step. So first thing is to train the model on the Alpaca dataset. So maybe we can just copy paste this command, and the training would start. So I've already like done the training and have all the output already created with me, but I'm just going to run this thing just to show you everything is like running fine without any error, so that you can also get a good idea. This is like a fully working repository with all the detailed steps. So one thing to note over here is this is like a 8-bit quantization model that we are going to use. So maybe let me open this file and let's deep dive into this. So under the train folder, we can see the supervised fine-tune file. So this script is a LoRa adapter training file. It supports 8-bit memory efficient model training. So key steps are load the base model, then prepare it for 8-bit fine tuning, attach LoRa adapter and resume if there are like any checkpoints already available, and then build tokenized SFT dataset for the training purpose. And once our training is done, we just keep on saving all the checkpoints. So until the training is running, let us quickly go through the file. So this is a train configuration where we see the data path, which is the Alpaca. So as we start the training process, the dataset would be automatically downloaded from the Hugging Face, and this is the output folder. So LoRa Alpaca, so the model output would be get saved over here, which is LoRa adapter. Batch size is there, number of epochs are there, and we see LoRa R, which is LoRa ranking, which is basically a parameter which decides how many number of model parameters you want to train. Since it's LoRa, it doesn't train all the parameters which is there in the Llama 8 billion model. Using this rank, which is 8 in this case, it decides to use only some specific parameters which are required to train and not to train the whole model. So this is very much important because it saves us a lot on VRAM of the GPU for training. Getting ahead, so now we have the base model ready and some configurations, and now we see since we are like using 8-bit configuration, so we have done some configurations here. So here it says automatically like decide which device we want to train the model on, whether it be GPU, CPU, or a mixture of both. And now since we have this option of GPU offload, CPU offload as well, so if the GPU memory gets completely filled, it can also transfer some of its data to CPU to get it trained. Loading the model, use 8-bit configuration. So bits and byte config we are using to set it up. So now we have the model and the tokenizer ready. And since we are using 8-bit, so we are like preparing the model for 8-bit quantization and all. So this is the model and this is the LoRa config with the ranking and everything. If you already have a checkpoint, maybe resume it from there, or otherwise start the training. And we are printing some parameters of the model using this command. And using the data loader, we have now divided the whole data set into training and validation. And these are the training configs now. And using this particular command, train, we can start to resume the model if we already have a checkpoint. If not, start the training from scratch. And once the model is trained, we just save the checkpoint. So let me open my terminal to see what's the progress. So right now it's on 7th iteration of the training. Let it complete. So once it is maybe completed, it would be like saved in this thing. Since I've already done it before, it's already saved for me, the 7th iteration of the checkpoint. So yeah, let it complete. It will be just completed in some few seconds. Once this model is trained, I think it's done now. Yeah, the training process has now been completed. It again have replaced the files over here. Now comes the merging part. Now since we have already trained the adapter, we can merge it with the final base model to create like a one single model out of that. So we can just copy paste this command to like merge the adapter with the base model, which is Llama 8 billion parameter model. So it won't take like a lot of time to do that. And once it is done, it would be like saved in Alpaca adapter merge thing. So let it continue, and maybe let me till then show what is there in this particular py file. Script loads up PEFT adapter checkpoint and merges the adapter weights into the base LM model, producing a single merged model. So that is basically required if you want to deploy a standalone model in the production. And going through the script over here, so this is the PEFT model ID. So this is like the adapter that we have trained, and this is the base model, like the Llama base model. So in the PEFT model configuration, we are giving the base model, PEFT model ID, and using this command, we are going to like merge and save the output model to the adapter merge. So LoRa Alpaca adapter merge the model output, which got saved after this thing. Okay, now coming to the third step after the adapter got merged, now it's time to train the reward model. So as explained before, reward model is like a separate reward or like a LLM model, which is responsible for giving scalar values for the output which is getting generated from the LLM. So if the output is good, it would generate better rewards. If it is bad, it would generate bad rewards. So let me also open the file. So I've already started the training process so that it completes by the time I completely explain this trained reward model file. So yeah, this script loads a pairwise preference dataset. So let me also open the preference dataset that we already have. So it's like 64 MB kind of file with us with input. So user input is something like this, and it has two output, completion A and B. So in this kind of dataset, we are preferring completion A over completion B, and we are training a reward model so that it generates better reward for this kind of output compared to this kind of output. So we have this kind of dataset with us, and now let me open again the reward model training file. It generates two response. It has two response, basically J and K, and we are now using a loss function log sigmoid, where it like subtract the score of J from K and generate the loss function, and we just use it to like train the reward function. Some of the features, as we see, it's like again 8-bit quantized adapter that we are going to generate. Base model is going to be the LLaMA model, and it's like a Hugging Face classification model, LoRa adapter for parameter efficient fine tuning, and we have also custom data collator, which builds input J and input K pairwise batches, which is required to train the reward model. So seeing some script arguments over here. So these are like some default arguments. Skipping that, dataset directory we have provided to load up the preference dataset. Training arguments we can see over here. I think these are like the basic and standard ones. Tokenizer, device map auto, which automatically decide what to load the model and train the model on. And then we have the 8-bit quantization configurations again that we have seen before. This is the base model of LLaMA that we are now loading up. Prepare model for trainings, and this is the parameter efficient fine-tuning config with again LoRa rank as we have seen before. And this is reward data loader, which again the data set has been divided into training and evaluation data set that we got from this JSON file. Then there is like some collator class, which is essentially doing pairwise sample conversion into tensors so that we can easily train the reward model using the data set. Compute matrix again used for loss functions calculation and all. Reward trainer that computes pairwise preference loss between two responses. So once a reward model generates once the LLM generates two response, reward model again computes loss for those two responses which got generated. This is the config. So we are using the base model for the reward trainer, and some padding, evaluation, and training data set, and all these, like I think these are the basic things. So we can see over here, this is a model that got the parameter efficient 8-bit quantized LLaMA model that we have over here. So basically you can say this is a reward model, which has the base model as LLaMA, but we are training it to give out like some scalar value, which is basically the rewards for the output. So once it gets trained again, it gets saved to the adapter folder, which is this one. So let us see if the training got completed. So I think, yeah, the last training command that we have over here is now done. So now it's time for the next step, which is merging this adapter again to make the final model, the reward model. So we'll just merge that. So we are already done with this command. Now it's time for this command, fourth one, which is the merging part. So let me open a new terminal and paste this command. So again, what happened? Something wrong, I don't know. Okay, so now we have ran this merge peft adapter command, and if we see the input parameters, model name is basically the one adapter folder name that we have over here, and once this thing is completed, it would generate this folder up, since I've already done that. So this is like a new LLM model which is responsible to generate reward scalar score. So once this thing is done, as we see over here, now it's time for the final step, which is PPO-based tuning, which is the SFT model and the reward model are going to work together and generate like a new model which is more efficient and which has inside the preference dataset that we have trained it on. So let me just copy paste this command. Let me open a new terminal and paste the command over here. So it will take some time to get the training completed. So by the time, maybe I'll explain what this file has inside it. So where's the file? Train reward model we have already done. Train LM with RL. So this is the file. So let me go to the top. So run PPO tuning against reward model using TRL. So TRL is again a Python library that is available for reinforcement learning based policy optimization and training. The script demonstrates how to fine-tune a casual language model. So PPO proximal policy optimization using TRL library. So the workflow looks like this. We load up the dataset. We generate response for all the dataset that we have. So that is generally called rollouts on the model that we have. So this is the model basically. LoRa Alpaca adapter merge. So we are going to use this model to generate output for all the input that we have, and then we are going to use the reward model, which is this one, to calculate the scalar scores. Once we have those scores, then we are going to run a PPO update policy to update the SFT model and generate a new model by saving up the checkpoint. So these are the steps involved in this file. These are the script arguments. Let me fold that because these are pretty standard and straightforward. Again, the PPO config as we see over here, model name and batch size and all those arguments. Then we have trained dataset, tokenizer, and in this class in this function we are building up the dataset, tokenize and filter the dataset into PPO ready input. So we want to convert the data in a way where it is easy for the model to ingest for PPO training. So moving ahead, then there's this collator function, convert a list of dictionary into batch of list, again required for PPO trainer. Then comes the LoRa config model and all that. So this model is basically this one, the LoRa Alpaca adapter merged. PPO trainer again came, and sentiment pipeline. So this sentiment pipeline is basically the reward model, the one which we just merged. So if I just go to the name, you can see it is coming from the argument, and in the argument, if you remember, we have given the name. So model name is one model name is LoRa Alpaca adapter merge, and second reward model name is the one which we trained and merged. So these two models are being used given from the arguments as seen over here. Coming back to the pipeline. So now this is the main part of the script where we are like running epochs on the entire data. And PPO trainer, so generate response from the current policy. So again, the LLM model, it generates response, and that response goes to the reward model as we see over here to generate rewards. And then these rewards go to the PPO trainer to like optimize the model. And once the model is more optimized, we continuously save checkpoints so that the progress don't get lost. And this is how the training process goes on and on. So we have like save frequency as 100, so until it reaches 100 iteration anything won't be saved, but I have saved some intermediate checkpoint before just to show you, so we can see the intermediate steps. So 33, 29 and all that has been saved previously when I ran. So I'm just going to close this training process now since I already have the checkpoint with me. So once your model is trained, now it comes to the inference part. So I have some like samples in my README where we can see the output of the inference. So let me show you. So this is the inference output from the base model, which is like already available. And we give the input as give 3 tips for staying healthy. And we just are going to run the LLaMA model, base model, to see the output, what it generates. And then we'll see after training what kind of output we see. Let me close up all the other terminals to avoid confusion. So it generated this output. So this is a base model output. After that, we generated the adapter. So we can use the script to load the base model along with the adapter. Or the other way is we can directly use the merged adapter SFT model. So let me use the second one to generate the output, which is from the merged model, which is this one. So we are going to see some different output from this thing, which is I think a lot better. It has points and everything because it has been fine-tuned on Alpaca dataset. And then after that, we have another model, which is the RLHF PPO trained model. So we haven't trained it till 99th epoch. So, but I can just show you after like running this inference command that it still run, and maybe on some intermediate step. I don't expect the output to be that great, but just to show you, okay, this thing runs. Giving the input, it should generate some output for the input that we have given. So it has generated something, but not like a good response because it's not trained till the end. But this is like a complete working repository that I have created for any one of you who are struggling to maybe train a model using preference dataset. So now you can use this repository as a reference to train RLHF based model and continuously improve your model. So everything, every detailed example and everything I'll be pushing to GitHub. So I'm providing the GitHub link in the YouTube comments. So please feel free to clone, fork it and use it for your own training purpose. I hope this video helps, and wish you guys also improve your model and do best in your life. Thank you.